This video is the second half of the video, or the video sequence that talks about AM modulation and demodulation. If you've not seen part 1 of this video, you should watch that first. In part 1 of the video, we basically got to the point that we have on the screen where we have this mess. Basically, what we have here is we developed what the spectrum of the AM modulated signal would look like. And this is a signal that gets broadcast. Now, the idea in the demodulator is we want to, we actually want to look at the radio receiver and figure out how this radio receiver is going to take the signal that we want, which is this one, and separate it from all the other signals that we don't want, these nasty green and brown and orange signals. These are from signals, or these are signals from stations that we don't want to listen to. And so basically what we need to do then is figure out how the AM radio does this. Well, I've actually drawn a picture here that shows, at least conceptually, how the AM radio does this. The antenna of the AM radio is hooked into what's called an RF amplifier. This is an amplifier that's actually also a bandpass filter. We then have a mixer and another bandpass filter and then a demodulator. And what we'll do is go through each of these steps and look at what's happening in this system in the frequency domain. So let's first look at the frequency domain representation of what's coming in from the antenna. And to do this, we'll get an empty page. Again, coming in from the antenna, so this is at point A in the system. In the frequency domain, I have something that looks like this. I have out here at omega c the information that I want, and also at minus omega c. But I also have all of these signals from all the other radio stations that are broadcasting and that my antenna picks up. So I've got lots of stuff here, and the issue is that I don't want to listen to all this other stuff. I want to listen to the one station that I'm tuned into, the one that's at omega c. And so that brings us to the next step. If we go back to our diagram of the demodulator, or the radio, I have what I call an RF amplifier. The RF amplifier takes the signals coming in from the antenna, which sometimes are very small, can be millivolts or less, and amplifies them, and then also it's a tunable band pass filter. Okay, and so what this RF amplifier is going to do is start to get rid of the stations that I don't want to have. So if I go back to my other window, we'll draw the frequency response of this tunable bandpass filter. We'll draw it in blue because it's a nice useful thing. Now it turns out that this tunable bandpass filter is not a very good bandpass filter. And the reason for that, this again is the magnitude spectrum of the, magnitude spectrum of the frequency response of the tunable bandpass filter. And you can see that the pass bands, or the pass band, is at omega c, and as you get farther and farther away from omega c, that the frequency response gets smaller and smaller. So it does get rid of frequencies that are not at omega c, but it doesn't do it very effectively. Again, the reason for this is that this is tunable, so you can actually change the center of the pass band so that you can center it on the frequency that you're interested in, the frequency of the station you want to listen to. So the output of this RF filter, which I'll label B, and we'll show where this is on the AM radio right here, is going to be the product of the frequency content going in and the frequency response. So you can see that my station that I'm interested in comes through this filter pretty much unscathed. Here, actually, let's do that in red, because I take this part of the filter and multiply it by the signal I'm interested in, and it does pretty good. So out here at minus omega c, I have the same thing. The other stations, these ones that I'm not interested in, they're multiplied by parts of the frequency response of the filter that are getting small, and some parts of them are multiplied by things that are very small. So I get stuff that looks like this. Okay. Now, because my bandpass filter does not have a sharp cutoff at the edges of the pass band, these guys are still pretty significant. They're not gone, but they're the junk we don't want to listen to. Okay. And so at the end of, or at the output of my RF amplifier, I have something that looks like this. And now I need to look at what happens in the mixer. So what comes out of the mixer? To do that, well, you can see that what the mixer does is it multiplies my signal at B by cosine omega LOT. Omega LO stands for the frequency of a local oscillator, and it's equal to omega C minus omega IF. Omega IF is the frequency of an intermediate, or it's called the intermediate frequency, and in AM radios this is 2 pi times 455 kilohertz. This intermediate frequency is different in FM radios and in analog television sets. You can actually set this intermediate frequency to be what you need it to be in order to make your design work. So let's go back to our pictures of the frequency domain and see what's going to happen here. Okay. I'm multiplying by a cosine in the time domain, which means I'm convolving by the transform of the cosine in the frequency domain. And the transform of a cosine in the frequency domain is just a delta function, in this case at omega LO, and another delta function at minus omega LO. And convolving, again, since I'm multiplying in the time domain, I'm convolving in the frequency domain. So I have to take this waveform that I've drawn here and convolve it with these two delta functions. And when I do that, I get a shifted version, or I get a shifted copy of this frequency waveform centered at both of the delta functions. So I'm going to get a copy where the origin gets moved down to omega LO, and another copy where the origin gets moved down to minus omega LO. And so that means that the omega C term, this big chunk of stuff that I want, will be copied up here. I'll get another copy of the stuff I want here, and then another copy, or I'm sorry, that was the wrong way to say that. The stuff over here is all part of this first copy. Then I'll get another copy down here and another copy down here. So let's see what on earth this actually ends up looking like. Okay. So the copy that shifts everything to the right, I've now got the station that I'm interested in up here, and this is at omega C plus omega LO. I've got another bump up here, which is at minus omega C plus omega LO, and these guys still have all the garbage following him around from the other radio stations. Now I have another copy going this direction. I get a copy here at omega C minus omega LO, and another copy down here at minus omega C minus omega LO. And I still have all the junk associated with these guys. Okay, but so what's happened by using this mixer is I've got two pieces of I've got the radio signal that I want to listen to at omega C minus omega LO, and if I've done this correctly, this is actually omega IF and minus omega IF. So I basically have the radio signal that I want at this intermediate frequency. So if we go back to our picture, I now know what C looks like. It's got the radio signal that I want at the intermediate frequency. This bandpass filter is now a bandpass filter that has very sharp pass bands. And so the output of the bandpass filter, again, it has a transfer function that looks something like this. And so when I run the output of the mixer through that bandpass filter, then the only thing that's left, is the radio station that I'm interested in at omega IF and minus omega IF. And that's the miraculous part of it. Okay, so now I actually have the signal that I want. I've got it isolated at a particular frequency, and the only thing left to do is to reconstruct the signal, take it from this intermediate frequency back down to what's called baseband. That's the frequency band that the signal occupied when it first started out. That's done by a demodulator, by this guy here. And because I'm out of time and the demodulator is nonlinear usually and gets kind of messy, I'm actually not going to talk about how that's done. I'll leave that as an exercise to the interested viewer to see how that's done. So this pretty much wraps up the discussion of AM modulation. Again, we've been moving things all over in the frequency domain, and that's how you understand what's going on in an AM radio, is in the frequency domain.